Hi guys, let me welcome you all to another lesson. Today we discuss the principle of superposition. So the scenario goes as follows. It says a teacher uses a spring. So the medium that the teacher uses here to generate the pulses is a spring. And in this particular case, the teacher generates two pulses, A and B. The two pulses move towards each other along a spring and meet at point P, as shown in the sketch below. So the first question says, define the term transverse pulse. So a transverse pulse is a single disturbance where the movement of the particles in the disturbance is in an upward-downward movement. So essentially they vibrate upward and downwards. And the movement of the particles, or let me say the direction of the movement of the particles, is at a right angle to the movement of the pulse itself. So when the direction of the movement of the particles is at a right angle to the direction of the pulse, then we say the pulse is a transverse pulse. So number 2.2 says write down the term of the type of interference that occurs when the two pulses meet at point P. So you'll notice on the sketch that the first pulse has a positive displacement of plus 20, and the second pulse has a negative displacement of negative 10 millimeters. So when these pulses meet up at point P eventually, the smaller pulse will have a weakening effect on the bigger pulse. So the type of interference that will occur at point P will be a destructive interference. So when the two pulses eventually overlap at P, you'll see that the pulse with a negative displacement has a weakening effect on the pulse that has a positive displacement, thereby creating a pulse with a shorter amplitude. It's sort of like this one takes away from the bigger pulse, resulting in a pulse with a shorter positive displacement. That's why we say the resultant pulse is a result because of destructive interference. So the next question says calculate the amplitude of the pulse that forms when the two pulses meet point P. Show your calculations. So we saw earlier on that pulse A has an amplitude with a positive displacement, and pulse B is an amplitude with a negative displacement. So the resultant amplitude at P will be the sum of the individual amplitudes, which is the amplitude of A plus the amplitude of B. So the amplitude at A is a positive displacement, which is 20, and that at the one at B is a negative displacement, negative 10. So the resultant displacement will be 10 millimeters. So the next question says write down the term for the principle you applied in 2.3 above. So the principle that we applied is the principle of superposition. So the principle of superposition states when two pulses move in the same space at the same time, they overlap, and the amplitude of the resultant pulse is the sum of the amplitudes of the individual pulses. So number 2.5 says how do the speeds of the two pulses compare? Write only A greater than B, B greater than A, or A equals to B. Explain your answer. Well, we saw in the scenario that the pulses are created by the same medium, which is a spring. So the pulses therefore move at the same speed. So we can say A equal B 2.5, we can say A equal to B, and the reason is the pulses were generated by the same medium, therefore having the same speeds. Thank you for watching. See you in the next one.